Hi everyone. Today we're going to study Chinese remainder theorem. This is the Chinese remainder theorem or CRT. Let m sub 1, m sub 2 up to m sub n be pairwise relatively prime positive integers greater than 1. And a sub 1, a sub 2, up to a sub n, an arbitrary integers. Then the system x is congruent to a sub 1 mod m sub 1. X is congruent to a sub 2 mod m sub 2. Up to x is congruent to a sub n mod m sub n. Has a unique solution modulo capital M is equal to m sub 1 times m sub 2 times up to times m sub n. Now this is the formula for the CRT. X is congruent to the quantity a sub 1 times capital M sub 1 times capital M sub 1 inverse plus a sub 2 times capital M sub 2 times capital M sub 2 inverse plus up to plus a sub n times capital M sub n times capital M sub n inverse, and this is mod capital M. Let us see this example. Solve the congruences. X is congruent to 1 mod 5. X is congruent to 2 mod 7. X is congruent to 3 mod 9. X is congruent to 4 mod 11 by Chinese remainder theorem. First, we note here that the moduli 5, 7, 9, and 11 are relatively prime. We have here 4 congruent equations, so the formula or the CRT value of x is congruent to the quantity a sub 1 capital M sub 1 times capital M sub 1 inverse plus a sub 2 times capital M sub 2 times capital M sub 2 inverse plus a sub 3 times capital M sub 3 times capital M sub 3 inverse plus a sub 4 times capital M sub 4 times capital M sub 4 inverse, and this is mod capital M. We write here the congruent equations. We can collect the values and put it in a table. It becomes like this. A sub 1 is 1, a sub 2 is 2, a sub 3 is 3, a sub 4 is 4. M sub 1 is 5, M sub 2 is 7, M sub 3 is 9, M sub 4 is 11. Based on the formula of the CRT, we need to get other values. We can put it in a table like this. We need capital M sub 1 up to 4. And then we need capital M sub 1 inverse up to capital M sub 4 inverse. We need also the value of capital M. Now let's start with this capital M. The formula is m sub 1 or small m sub 1 times small m sub 2 times small m sub 3 times small m sub 4. The values are here. When we substitute the values, we have 5 times 7 times 9 times 11. And the product is 3,465. We will write the value on this space. Now let's find the capital M sub 1 up to capital M sub 4. We have this formula. Capital M sub n is equal to capital M all over small m sub n. For example, we want the capital M sub 1. The formula is capital M all over small m sub 1. When we substitute the values, it becomes like this. 3,465, that is our m, all over the m sub 1, which is 5. So the quotient is 693. We write the value opposite capital M sub 1 on the table. Next, capital M sub 2. We have this capital M all over small m sub 2. Substituting the values, 3,465 over 7. And the quotient is 495. We write this value in here. Next is capital M sub 3. That is equal to capital M all over small m sub 3. So we have 3,465 over 9. The quotient is 385. And we write this in here. And the capital M sub 4 is equal to capital M over small m sub 4. So we have 3,465 over 11. And the answer, 315. So we write the value in here. Next is the inverse values. Let's begin with the capital M sub 1 inverse. Please note that we have a formula like this when finding the inverse. We say that capital M sub n times capital M sub n inverse is equal to 1 mod small m sub n. Suppose we want to get this capital M sub 1 inverse. We will write like this. Capital M sub 1 times capital M sub 1 inverse is equal to 1 times mod m sub 1. When we substitute the corresponding values, it becomes like this. 693, that is the capital M sub 1, times the capital M sub 1 inverse is equal to 1 mod 5. In here, what we're going to do is, we think of an integer, such that when multiplied by 693, then divide the product by 5. The remainder must be 1. We will do this by trial and error. We start with, suppose this M inverse is 1. So it will be like this. 693 times 1 divided by 5. We will see that the remainder here is 5. So this is not the value that we want. Next is when capital M sub 1 inverse equals 2. So we write 693 times 2, then divide this by 5. In here, we will see that the remainder is 1. It means we will stop here, and we will conclude that the capital M sub 1 inverse equals 2. So this value of 2, we will copy in here. Then we go for the capital M sub 2 inverse. It becomes like this. Capital M sub 2 times capital M sub 2 inverse is equal to 1 mod M sub 2. When we substitute the values, we have now 495 times capital M sub 2 inverse is equal to 1 mod 7. So we will think of an integer such that when multiplied by 495, then divide the product by 7, the remainder is 1. Let's begin with when capital M sub 2 inverse equals 1. So we will have 495 times 1, then divide by 7. The remainder will be 5. This is not what we want. Next, we go to when capital M sub 2 inverse equals 2. So this is 495 times 2, then divide by 7. In here, we will see that the remainder is 3. So this is not the integer that we want. Let's go to capital M sub 2 inverse equals 3. So we write 495 times 3, then divide by 7. The remainder will be 1. So from here, we stopped because the remainder is already 1. And then we conclude that the capital M sub 2 inverse equals 3. We write the value in here. We're going to use the same pattern for solution of capital M sub 3 inverse and capital M sub 4 inverse. It means it will be like this. 385 times capital M sub 3 inverse is equal to 1 mod 9. Also, this 315 times capital M sub 4 inverse is equal to 1 mod 11. When we evaluate this, we will find that the values of the inverses are 4 and 8 respectively. Now, the table values are complete. We're going to substitute the corresponding values in the CRT formula. This is our formula. So it becomes like this. X is congruent to the quantity 1 times 693 times 2 plus the quantity 2 times 495 times 3 plus the quantity 3 times 385 times 4 plus the quantity 4 times 315 times 8. Then we have this mod 3465. We simplify the corresponding products. We will have 1386 plus 2970 plus 4620 plus 10,080. Let us get the total here. We will get this 19,056 mod 3465. We can simplify this congruence into 1731 mod 3465. If we want to get the value of x, we simply add the two numbers. 1731 plus 3465. The value of x equals 5196. This is the final answer. I hope you learned something from this video. See you again next time.